Hello, welcome to Astronautics for Exploit. This is Dr. Ayeshola Ogundele. Asteroid Observation Strategies. The focus points of my presentation are as follows: Asteroid Observation and Asteroid Observation Strategies. Over the years, a lot of research studies have been carried out and are still being carried out on the formation of the planets and origin of life. Some research findings show that asteroids, remnants from the solar system formation, and believed to contain information about the events that predate millions of years of Earth's geologic information, could offer insights to humans' curiosity about the birth of the Sun, planet formation, and probably the origin of life. Asteroids provide both economic opportunities and hazards. Some asteroids contain precious natural metals that could provide wealth of quintillions of dollars, water that could be used in situ, and organic compound that could be mined. Some asteroids also have dangerous effects when they hit the Earth. Based on the economic status of the asteroid, a new frontier is opening. A new chapter of asteroid observation is opened by the advent of space travel. Before the space travel era, objects in the asteroid belt could only be observed using large telescopes, and this offers limited information about the shapes and compositions of asteroids and their spectral properties. In 1968, the first radar observation of the asteroid 1566 was made, and this marked the turning point. Since then, radar observation technique has been used and is still in use for the observation of the passing of near-Earth asteroids and comets, which are together referred to as near-Earth objects. The radar detections of near-Earth objects provide a better understanding of their orbits, data that can help humans to predict their future motions and predict possibility of an asteroid hitting the Earth. Several approaches, such as ground-based observations, space-based observations, space probe observations, and spacecraft flybys, are being used to observe asteroids. It has been postulated that one of the best tools to help protect the Earth against the impact of near-Earth objects like asteroids is ground-based planetary radar. The space-based observation equipment can detect more space objects than the ground-based observation equipment because there is no atmosphere to interfere in space, and they can observe larger portions of the sky. Many countries and private companies have launched probes to planets, asteroids, moons around the solar system. Asteroid observation. Asteroids, referred to as smaller solar system bodies, are the leftovers after the formation of the inner planets, including the Earth. There are millions of asteroid objects, and most of them are located within the main belt, between the orbits of Mars and Jupiter. This picture shows artist flight path concept of NASA's Asteroid spacecraft during its final flyby of asteroid Bennu. Until the age of space travel, objects in the asteroid belt could only be observed with large telescopes, their shapes and terrain remaining a mystery. Limited information about the shapes and compositions of asteroids can be attributed to their light curves, that is, variation in brightness during rotation, and their spectral properties. Illustration of asteroid deflection strategy is shown in this picture. Asteroids are rarely visible with the unaided eye Many of the asteroids are visible through binoculars or small telescopes. Asteroids appear star-like in a telescope. An asteroid can be distinguished from a star by its motion, typically 30 arcseconds per hour relative to the background stars. Asteroids are usually much closer to us at opposition than at other times, and are therefore brighter and easier to see. The concept art for 2016 WF9, discovered by WISE mission under the new WISE mission, is shown in this picture. Asteroid observation strategies. There are different strategies that are being employed in observing asteroids. Various asteroid observation strategies are using ground-based observation, space-based observation, spaceport observation, and spacecraft flyby. Ground-based observation. It has been postulated that one of the best tools to help protect the Earth against the impact of near-Earth objects like asteroids is ground-based planetary radar. There is a call for further development of radar systems so as to aid in planetary protection by imaging newly discovered near-Earth objects. This picture shows an illustration of the new radar system being developed. The data that can be obtained from ground-based observations are limited. This is because the asteroids are small. Large curve measurements can be made by the ground-based observation, and when collected over a long period of time, it allows an estimate of the rotational period, the pole orientation, and a rough estimate of the asteroid shape. This picture shows an asteroid shower on the Earth-Moon system. Near-Earth asteroids that come into close vicinity of the Earth can be studied in more details using radar system. Radar system provides information about the surface of the asteroids. For example, can show the presence of craters and boulders. Radar observations can also be used for accurate determination of the orbital and rotational dynamics of observed objects. This picture shows artist's illustration of the DART spacecraft aiming to smash into the asteroid Dimorphos. Radar observations of asteroids were conducted by the Arecibo Observatory in Puerto Rico and Goldstone Observatory in California. A dumbbell-shaped object with overall dimensions of 217 kilometers by 94 kilometers by 81 kilometers was shown by radar observations of the main-belt M-class asteroid Cleopatra. The asteroid surface properties are consistent with a regolith, having a metallic composition and a porosity comparable to that of lunar cell. This picture shows installation of asteroid detection radar dish antenna. Space-based observation. This is also being used to observe asteroids. Space observatories operate from beyond the Earth's atmosphere and are not hampered by atmospheric interferences. With space-based observations, there is long-running continuous observations for forecasting and research in space weather. Spicer Space Telescope is shown in this picture. Advantages of space-based observations. The space-based observation equipment can detect more space objects than the ground-based observation equipment because there is no atmosphere to interfere in space and they can observe larger portions of the sky. Space-based technologies, namely communication satellites, enable global telecommunication systems by relaying signals with voice, video, and data to and from one or many locations. This picture shows Hubble as seen from Discovery during its second servicing mission. Space-based observation missions. Some of the space-based observation missions are Near-Earth Object Wide Field Infrared Survey Explorer, Spicer Space Telescope, and Hubble Space Telescope. This picture shows artist's impression of a rocky and water-rich asteroid being torn apart by the strong gravity of the white dwarf star. Near-Earth Object Wide Field Infrared Survey Explorer. WISE is a NASA infrared astronomy space telescope in the Explorers program. WISE discovered thousands of minor planets and numerous star clusters. Its observations also supported the discovery of the first white-type brown dwarf and Earth-Trojan asteroid. This picture shows new WISE discovery image of comet C2020F3. In October 2010, NASA extended the WISE mission with a program called Near-Earth Object WISE. The new WISE mission uses a space telescope to hunt for asteroids and comets, including those that could pose a threat to Earth. During its 4-year survey, new WISE rapidly identified and characterized near-Earth objects, gathering data on their size and other key measurements. This picture shows illustration of artist's concept of a white dwarf discovered by WISE. New WISE discovered many new objects in the solar system, including 20 comets. During its primary and extended missions, the New WISE spacecraft delivered characterizations of 158,000 minor planets, including more than 35,000 newly discovered objects. This picture shows artist's concept of the Wide Field Infrared Survey Explorer. Spicer Space Telescope. The Spicer Space Telescope was an infrared space telescope launched in the year 2003. Spicer Space Telescopes observed more than 700 near-Earth asteroids. These observations determined rough sizes of the majority of observed objects, but provided limited data about surface properties, such as regolith depth and composition, angle of ripples, cohesion, and porosity. This picture shows artist's concept of the Spicer Space Telescope. Spicer was the third space telescope dedicated to infrared astronomy. The first two are IRAS and ISO. It was the first spacecraft to use an Earth training orbit, which was later used by the Kepler Planet Finder. Spicer was placed into a heliocentric as opposed to a geocentric orbit, trailing and drifting away from Earth's orbit at approximately 0.1 astronomical units per year. This picture shows an illustration of a brown dwarf combined with a graph of light curves. Infrared astronomy. Spicer was the third space telescope dedicated to infrared astronomy. Spicer was placed into heliocentric orbit. This picture shows Spicer's first flight image of 1C1396, launching into low Earth orbit. Hubble Space Telescope. Hubble Space Telescope is one of the space-based observation mechanisms. The Hubble Space Telescope is a space telescope which was launched into low Earth orbit in 1990. Hubble is one of the largest and most versatile, renowned both as a fighter research tool and as a public relations bone for astronomy. The Hubble telescope is named after astronomer Edwin Hubble and is one of NASA's great observatories. This picture shows Hubble Space Telescope as seen from the departing Space Shuttle Atlantis. Hubble is the only telescope which was designed to be maintained in space by astronauts. 5 Space Shuttle missions have repaired, upgraded, and replaced systems on the telescope, including all 5 of the main instruments. Accommodation of regular servicing. Hubble was designed to accommodate regular servicing and equipment upgrades while in orbit. Instruments and limited life items were designed as orbital replacement units. This picture shows deployment of Hubble from Discovery in 1990. Space maintenance of Hubble. Asteroids were studied by the Hubble Space Telescope, such as tracking the colliding asteroids in the main belt, breakup of an asteroid, observing an active asteroid with 6 comet-like tails, and observing asteroids that were chosen as targets of dedicated missions. This picture shows images of the Eagle Nebula that demonstrate Hubble's ability to capture stunning images in both visible and infrared light. Space probe observation. This is another form of observation that is being used to observe asteroids. A space probe is an artificial satellite that travels through space to collect scientific data. A space probe may orbit Earth, approach the Moon, travel through interplanetary space, fly by, orbit, or land or fly on other planetary bodies, or enter interstellar space. This picture shows Hayabusa space probe. Many countries and private companies have launched probes to planets, asteroids, moons around the solar system. Near-Earth Asteroid Endeavour mission was a robotic space probe mission which was designed to study the near-Earth asteroid Eros from close orbit over a period of a year. This picture shows an artist's rendering of NASA's near-Earth asteroid Rendezvous spacecraft at asteroid Eros. Space probe Shoemaker. On February 12, 2001, NEA spacecraft landed on asteroid Eros. It was the first spacecraft to successfully orbit an asteroid and land on an asteroid. The NEA spacecraft settled on a saddle-shaped depression of the asteroid Eros and then continued transmitting signals to Earth. This picture shows illustration of asteroid Eros' southern hemisphere, a cratered terrain where the NEA spacecraft touched down. Space probe Osiris is a NASA asteroid studying and sample return mission. The mission's primary goal is to obtain a sample of at least 60 grams from 101955 asteroid Bennu, a carbonaceous near-Earth asteroid, and return the sample to Earth for a detailed analysis. This picture shows an artist's rendering of Osiris collecting samples from an ancient asteroid known as Bennu. Spacecraft flyby. A flyby is a spaceflight operation in which a spacecraft passes in proximity to another body, usually a target of a space exploration mission, and/or a source of a gravity assist to impel it towards another target. Flyby maneuvers can be conducted with a planet, a natural satellite, or a non-planetary object, such as a small solar system body. This picture shows NASA's Asteroid Redirect mission aims to capture a boulder from a large asteroid and park it in orbit around the Moon by 2025. Flyby spacecraft. Flyby is also used to describe when, for example, an asteroid approaches and coasts by the Earth. A flyby spacecraft has a limited opportunity to gather data. Once it has flown by its target, it cannot return to recover any lost data. Flyby missions only require that the spacecraft leaving Earth crosses the path of the target body. The Moon is a specific case as it orbits the Earth. This picture shows illustration of Osiris spacecraft attempting to retrieve samples from Bennu's carbon-rich surface. Spacecraft flyby craft. Comet Rendezvous asteroid flyby was a cancelled plan for a NASA-led exploratory mission. Craft was scheduled to conduct a close flyby of a main belt asteroid flying information with its short period comet to study it during both active and quiescent phases and deploy a penetrator or lander into the nucleus of the comet to determine subsurface properties and composition. This picture shows a conceptual image of NASA's Orion spacecraft approaching a robotic asteroid capture vehicle. Craft's primary objectives are to determine the composition and character of a cometary nucleus, to characterize the cometary atmosphere and ionosphere, to determine comet tail formation processes, and characterize the interaction of comets with the solar wind and radiation, and to characterize the physical and geological structure of an asteroid. This picture shows conceptual artwork of the Craft spacecraft deploying a penetrator. For more information, contact Astronautics for Exploit. You've been watching and listening to Asteroid Observation Strategies, presented by Dr. Anyashola Ogundele, Astronautics for Exploit, with the focus points Asteroid Observation and Asteroid Observation Strategies. Thank you.